Well, hello folks, and welcome to episode 168 of Retro Power and Cut. And you come to us at the last episode of 2023. So here we are in the fabrication shop again, same as every week. We're going to start off this time with the Interceptor, which I think we did last week, and there's some slightly different jobs going on this time, so I can elaborate in a couple of other directions. We're going to start with the thing that hasn't changed. Well, it has changed, but the job is still the same job as last week, which is building in the HVAC system into the car. And I noticed a couple of comments regarding building the car around the HVAC, which are not far from the truth in reality. And Stu's getting on pretty well with that now. He's got the structure built into the bulkhead and the reinforcement put in, and the box, the actual sort of container that the Vintage Air generation, I can't remember if it's generation 4 or generation 5, anyway, the newest generation 5 Vintage Air HVAC system is going to live in. He's had to do a little bit of work to accommodate the fan, which again I mentioned last week, but he's got all that sorted out. He's put the suspension through its travel, checked the wheel for clearance because it's getting pretty tight on the wheel on lock on the piece of the inner wing that's sculpted around the SPAL fan housing. So we've got a little bit of fun and games getting the ductwork in for that. We're feeding that with air from the side, the gill vent on that side. So we've got a bit of work to do there, but the benefits of 3D printing, particularly now we can 3D print reinforced nylon parts in-house, filled nylon. We can print our own filled nylon parts, so that's a big step forward now in that we can do a multi-piece duct printed in a durable material that will actually be the finished part there, so that makes life a lot easier and quite a lot cheaper actually for the customer, so that's quite handy. So that's what's going on that side. Stu's making good progress there. There's been a couple of steps forward and backward in terms of just squeezing everything in and making it look really neat, as you can imagine, but he's pretty much there with that now. And then the other work that's going on is Tom has now been able to properly get his teeth into looking at the panel fit up on the car, and we knew there were a variety of issues to address, and there are indeed a variety of issues to address, and he's just started sort of, it's a sort of wacko rat scenario. You find rat pops its head up, you whack it back down. So the first step was to sort out the leading edge of the quarter panel, because that's a pretty fixed point along the whole side of the car. That's a point you kind of need to be right to start with. You get that right and get the door right, and then work forward now from that, matching everything else. So he's got the leading edge of the quarter right, but in working on that, he picked up that the profile change was a bit strange along the top of the quarter into the door shut to get it matched to the door, and we were losing crown in the panel. If I gesticulate to explain this, we were losing crown in the panel here faster than we thought we should be doing by the time we get to here where Tom has been putting the lead work in. This lead work isn't finished, I hasten to add. This is just roughed out at the moment. But this shape here, this crown here, was flattening off quite quickly here to get the shut line right to the door. But the wing, when Jamie reverses up now, you'll be able to see here, there's a large crown in the wing. And something just didn't match up. So we started looking at the shape of the door and realised actually that because the whole car, everything's kind of dull colour, it's hard to pick up the shape. But the door was far too flat. This section of the door at the top was far too flat. So that needs editing, and it's not really editable with the door skin attached to the door. Let me put my drink down. It's not really possible to adjust. I'll show you here. It's not really possible to re-crown, to put the curvature into this piece of the door with it attached to the frame, because there's a large quantity of bits of frame in the way, and there's an inner reinforcing structure here. And the only way to crown that, well, there are a number of ways to crown it, but all of them involve stretching that metal and rolling it to some extent, and that would involve hammer and dolly work, potentially a little bit of wheel work, and certainly a bit of bending work. None of that's possible while it's all attached to the frame. So to reprofile that means removing it from the frame, and it's spot welded on all sides and rather thoroughly spot welded. There's an awful lot of welds, so the door skin would be in a pretty poorly state by the time it is removed from that door. So we've elected to get some replacement door skins, which may or may not be the right shape. Now as it is, they appear fairly good. We picked them up from Martin Roby Panels this morning. and they actually appear reasonably good. And they've certainly got a lot more curvature just there. You won't see it on camera, you can barely see it like with me looking at it, just because of this dull grey finish. But they've got a lot more curvature there than the other ones had. And the benefit to this is that Tom can now mock-up fit this with good edges. He hasn't got shredded edges to sort out and holes from all the spot welds to sort out. You can trial fit that door skin and keep working on the shape of it to make sure that it's completely correct before it's spot welded on. So that's the way forward. We've got 2 more door skins. Those are going to get perfected before they go on the doors. He's currently stripping the skin off the second door, and then he'll be stripping the skin off this door because they're both the same problem. And then that's the next step forward. We'll be getting the skins profiled properly, getting them onto the frames, mocked up, and then welded on. And then he can carry on and continue work on the side of the car and continue work on the back edge of the wing. Basically, the panel gaps have been adjusted on the car. It's not terribly, you know, they weren't right, but they weren't appallingly bad. It's just that the door wasn't the right shape to start with, and then the panel edges had been pushed and pulled and adjusted to get the gaps reasonably consistent, if extremely large, and that had caused curvature on the edge of all of the panels. All of the panels have sort of came in to meet, so they were level. The edges met, but then they were bulged on the approach to that edge, and it just means that none of the panel, you know, none of it could be prepped for paint in that condition. So it all needs rework. But that's progressing now. We've got a way forward. It's a pretty clear path forward. It's quite a lot of lead work required, but I refuse to believe that Interceptors, I'm quite sure they had an awful lot of lead in from the factory. The gaps are pretty large without the lead, and given that a lot of these were Italian, but were built by Vignali, and then some were built by Jensen as well, I very much doubt that the craftsmanship was particularly great. Certainly, my experience with Italian built cars is they are very pretty to look at, but the metalwork leaves quite a lot to be desired under the skin. They're pretty rough and ready, and I suspect these were much the same. But I don't have an infinite knowledge of these. I've looked at quite a few Interceptors, but not in sort of huge detail. Having seen the scale of rust they suffer from, I can assume that the under the skin construction was not exactly great. So yeah, that's where we're at with that. Basically getting all the panel alignment good, getting all the panel gaps and fits all good, getting everything correct and lined up, and that's progressing quite well actually. We've got a clear path forward, and we've got a plan, and I'm not seeing anything that's frightening me too much in getting that fixed. So that's where we're at on that. We go past a gap here where there was a Redux E30 M3, so we're going to walk on from that gap and go into the body prep area, because earlier in the week we blasted and zinc metal, we re-blasted. Again, I always touch on this and I've been picked on it for repeating myself, but we always re-blast the car after we've done our metal work. We find it's the best way to achieve a number of things which are quite important. One is that any new metal put in, we use cold rolled mild steel for any new metal, any new sheet metal that's put into the car. All of that has quite a hard skin on it, and it all needs preparation for any coating that goes over it. Obviously you can't just be wiped and coated, it has to be abraded, and doing that by hand is obviously quite laborious, quite time consuming, and in the case of corners and detailed areas, actually really quite tricky to achieve. It's much easier to achieve with a blaster, with crushed glass media, which is what we use. So it achieves the keying up of new metal. It then cleans up any corrosion that might have happened during the fabrication work, which was pretty minimal on this, but there are a few areas. We put a very light coat of an etch primer on the body shells after the initial blast, right at the beginning of metal work. But in places where that's been heated or missed or sanded off, we get little bits of corrosion. So there's little bits of corrosion to blast back off. And then where the car is seam brazed, all these this is Sufsil Copper 968, basically silicon bronze seam brazing. Where the silicon bronze is put on, obviously the seams are heated up and you get some tarnishing, oxidising and general disturbance of the etch primer over those areas, and you wouldn't want to guarantee the adhesion of it, so that really needs blasting off as well. So the whole lot needs keying, new metal needs keying, and everything needs cleaning. The easiest way to achieve that is just to re-blast the car rather than trying to sand into every corner. So we re-blast the car, and the other point is you have to blast to a white metal, it's sort of known as in the blasting trade standard, before you apply the zinc metal spray, which is this coating here. That will only adhere properly to a surface blasted to a full white metal finish. I can't remember the actual term for that in blasting trade. It's an SA something or other surface condition, but basically it's got to look like white metal. It looks pretty similar to how it looks after it's zinc metal sprayed. So that's achieved that and got that ready, got the zinc metal spray on, and then there's a sequence of events leading up to being able to put the carbon panels onto this car, and the first one of which we were sort of going through this backwards and forwards a bit yesterday, because although we're kind of planning a sequence of builds, there's a couple of differences as we go along. So the sequence may not always be identical because it depends a little bit on the nature of the panels being fitted. But Gaz is quite right in saying, realistically, regardless of the process, the next step is the seam sealing. So he's getting on with the seam sealer work, getting all that finished off. There's a few areas where, despite the first and second blasting operations, there were little bits of original seam sealer left in a couple of areas, so he's been raking that out, dragging that out of some of the seams where that was left. Tend to find with German built cars, VWs and BMWs, the seam sealer is pretty tenacious stuff and they use quite a lot of it, and it's quite hard to get out of some of the little corners, so sort of have to just manually rake that out in a few places. So he's got that out, getting the new seam sealer in, and then we'll be putting a U-Pole Raptor coating on various areas at various times on this. We've got to coat the areas that are covered by the final bodywork, obviously, because we can't then get at those to recoat them after that point. And then there are various areas where there are different coatings for the inside of the car to the outside of the car, and there's still a couple of confirmations to be made on that. So I'm not going to go into all the detail on that because there's a couple of areas we don't actually know yet. But basically, guys, are just getting this ready for the Raptor coatings to go on. So that's where we're at on that. And then in the background over there, which Mark was working on, Mark's not there at the minute, I think Mark might be doing something next door, but is the Churchill two-door Mark II Jaguar, which is progressing pretty well. It's being the level of task that we expected, which is pretty tricky going. There's a lot of work in getting all the shape right all over the car, which is kind of understandable given that nearly all of it's fabricated from scratch. There's quite a few challenges around the rear quarters, just getting the lines to flow nicely, keeping the swage lines all clean, keeping everything all correct. It's been fighting us a little bit around the rear arches, and we've had a little bit of trauma with these door tops, getting the lines to flow properly as well, so we've had to do a bit of rework on the top of this door. But it is coming together quite well now. The basic shape is all there. There's still adjustments needed. You know, every day brings up a new little area where we have to do some more tweaks. Usually come back in with a hammer and dolly somewhere and adjust something, but that is the nature of the beast with this kind of thing. It is a test of everybody's patience, but it comes with the territory. And as I say, it's not so different from any one job to any other job. It just presents its challenges, and once it's all done and all in its final colour, it's going to look pretty impressive. But let nobody tell you it's easy. Marching on from that, we'll have a wander over to the Allegros. We'll go and see what Bobby and Sam are working on over there. Because we're in the latter stages of metalwork on these cars now. We're at the detail sections. I've mentioned it before, I'll mention it again. We're at the detail sections. So starting at the front, because it's right in front of me here, Bobby's been working on, one of the areas Bobby's been working on is getting the wiper mechanism all installed in a line. Now this is an original Allegro one. Then it will be replaced with the same type of system, but all new parts. This is an original Lucas motor, with the new ones are basically the same, just new. So that's now mounted in its final place. There's going to be a nice cover made to go over this, because they're not a very pretty item to look at the best of times. I don't like using covers on things. It always seems like a bit of a bodge. But there's not really a way to make that unit look particularly pleasing, so we're going to put a cover on it. And then he's got that grommeted through into the air intake scuttle for the HVAC unit, and then that tube then carries on through there and operates the 2 wiper boxes. That's all done, the curve's put on the tube, everything's aligned there. So that's all gone well. The next stage in the engine bay is getting the electric power steering unit mounted. We're using one of these XGM units. I believe there might be an NSK made unit. I can't actually remember now who manufactures them. They're fitted to quite a lot of production cars. That one is from, I can't even remember what era, but it's a Vauxhall Astra anyway. I can't remember what particular year it would be, but it's a Vauxhall Astra unit. It's relatively simple to control. It doesn't need CAN bus control. There are other versions of that pump that do need a CAN bus control. That one doesn't. So we're going to use that on this, on both of these cars, but it's just the finalising of the position of that depends on the airbox, and I've got a bit of a wait for the carbon airbox. It's probably my mistake, I should have ordered it earlier, I didn't. We've got a little bit of a wait on the airbox to enable us to just work out where we can get this pump in the space we want to get it into, down there above the steering rack and behind the alternator, and still actually be able to put the steering fluid in. That's the only question, whether that's actually going to get in the way. So that's another step to resolve on that. In the meantime, Bobby has also been sorting out, or has made the first prototype, if you like, of the door window mechanisms. You see the windows sort of held up by the suckers there. We've used mini electric, like classic mini electric window motors, and modified them to fit in these doors, because they're a very slim unit. The doors are quite thin on an Allegro, not as thin as a Mini, but they're quite a thin door. There's not a lot of room for the glass in the motor when the glass is down, and the Mini one solves that problem by being very, very slim. So Bobby's sorted out and drawn up the parts to enable that to couple to the Allegro glass and the Allegro glass mounting runner at the top. And also to mount into the door, and a couple of little bits that need adding to the door. So he's got one of those working, and then Sam's now picked up getting those all, getting the other 3 basically all put together, getting the mountings made, because there's a couple of modifications in the doors. Bizarrely, the doors are actually different from one side of the car to the other, so the door frames are different. So the same parts don't fit both sides of the car in any case, because the door's different. But Sam's working on that now, getting that so that the wiper mechanism, the window mechanism, can be mounted up in the near side door on this car, and then both the doors for that car have also got to be done. That's that. And then moving on from that, Sam's also been getting on with some rust repair on here. He's done a very nice job. The other cars pretty much, well, basically rot-free, completely rot-free on the areas that we had to deal with. But this car had some rot in the front and rear screen apertures. So both of the rear corners had a reasonable amount of grot in them. In fact, if I walk around this side, I can actually point at the area. But I can't shut the boot lid. Can I shut the boot lid in a minute? Yeah, shut the boot lid down. Click that. You see, this is the gas-assisted boot lid arrangement that we've got now. But yeah, this corner was probably the worst area, where there's a drain hole, and it had some rot through both sides of the drain hole. So Sam's done a nice job of fabricating a new corner section for the rear screen, getting that all cut in. The actual rail that mounts to underneath had rotted as well. The flange that welds to underneath had rotted. The edges of that had gone as well. So he's made the new top section, made the new bottom section, scribed them, cut them in, TIG welded all that in, and got it all metal finished. At some point later on, we'll trial fit the screens just to be sure that nothing's changed, but I'm pretty confident it's not. The curve all looks correct, so I don't think anything's gone anywhere there, but we will trial it just to be sure. So yeah, the front and rear screen apertures are now repaired. They're all looking good. So Sam's now on with the door windows. We've got some rust repair to do in the floor of that car, of the red car, or was the red car, and my current thinking, I may have mentioned this before, my current thinking to repair that is to take a polyurethane resin cast of the floor in this car and then hammer form a new floor section into it, because it's quite complicated. We can't do it on the Pullmax because there's a lot of transitions in it. It doesn't really lend itself to that. It could be all hand chased completely manually, but there are quite a lot of profiles in the floor, so it would take a long time to just chase it over an edge of an anvil. So I think we're probably going to try, and I've not done it before for this type of application, but we're going to try and do a resin cast off the floor and see if we can chase it into the resin cast, because I think that might be the best way of getting all the detail in that section. But to do that, we need to take the cast off the underside of the floor. Because of the shape of the floor, I don't think it's going to be very easy to chase in if we take the cast off the top, although it'd be much easier to take the cast off the top. I think we need to cast off the underside. So this card is to come off the jig and onto the rotisserie to do that. It's pretty much at the point of being able to do that, but there's no point probably doing it now when we're only one day away from finishing for Christmas. So we'll do that in the new year. I think we'll get this car onto the rotisserie, we'll move this jig out of the way, put this car on the rotisserie in this bay, and flip it upside down and try and get a partition off a section of the floor pan and take a polyurethane resin cast of that, and try and beat the floor section into that as a tool. So that's pretty much where we're at on that. And then the final thing sort of going on in here is that at the beginning of the week, I say beginning, I think it was actually, it may have been yesterday actually. I say beginning of the week, it was actually yesterday, it was Wednesday, and today is Thursday. When we blasted the Redux BMW body shell, after the clearing up had been done, after Rich had done the clearing up for that body shell, we bead blasted the Jaguar engine block and cylinder head, all assembled for the Churchill project. It was the best way we could come up with for cleaning up the engine block. I think we may have mentioned it before, but we used glass bead, and I've just used it as expendable media. Obviously you wouldn't normally do that, you'd normally collect it, but I've just done the job in our blast room using a small pot blaster. Just use the glass bead in there, just use it as expendable, let it just go into the blast room, and then bead blasted the engine block and head, and that's worked really, really well. It's actually come up really, really nice. So again, in the new year, we'll pull the head off, pull all the blanking pieces off that Adam has put on to prepare the engine for that. We'll strip it all back down. Undoubtedly some media will have got in somewhere. It always does, no matter how much you blank everything, some of it gets inside somehow. I don't know how, but anybody that's dealt with any shot blasting or sand blasting will know this. However well you plug something up, you could make it impervious, you could silicon sealer up every single gap. I guarantee you'll still find there's media inside it afterwards. I don't know how it gets in there, but it doesn't really matter. You know, the block was cast originally. Obviously that one was actually die cast, but even if most engine blocks are sand cast, you can get all of the media out as long as you're fastidious about it and you make sure you removed every closing plug and bung from that block, so that every gallery, every waterway, everything is completely accessible. So the next stage with that block is it's got to go off for machining. So we're going to we'll take all the plugs of it, strip it back down to the bare block, go for machining. When it comes back from machining, the machinists will wash it anyway. When we get it back, we'll re-wash it and we'll actually put it through our hot wash, and then we'll steam clean it and jet wash it outside with the jet wash as well. And that way we can be completely sure. We'll brush out all the galleries, we'll jet wash all the galleries out, and we'll just make sure it's all completely clean, so there's no chance of having any glass bead media left in anything. I'll pick up on a comment from a long time ago at this point. Actually, I've got a couple of things to pick up on, questions and answers, only minor ones because I've had a quick read through the questions. Contrary to a couple of comments, we do read a lot of the questions actually. But a point that somebody made to me a while ago, or I've seen people make, is, why not get these things a couple of things. Why not get them dry ice blasted? We've done that. It doesn't touch corrosion. I've used an extremely powerful, like a 250 CFM air requirement CO2 blaster, and that will not touch corroded aluminium. It doesn't even touch it. You can spend 10 minutes on 1 square inch and it will not remove the corrosion at all. It removes oil tarnish, it removes dirt incredibly well. It cleans dirt that you might remove with a jet wash or a steam cleaner. It removes really, really well. It will not touch corrosion. So another thing I see asked quite often, why not use soda? Soda removes things reasonably well, just like crushed glass does, and yes, it washes away and you can get rid of it, but it doesn't really remove corrosion from things properly. It doesn't really get in. It's far too soft a media. It doesn't really cut, and it won't remove aluminium corrosion properly. And when it does remove aluminium corrosion, if you're extremely laborious and consume loads of time, you will eventually be able to remove aluminium corrosion, but it leaves the surface dull. And it doesn't look, and it corrodes really quickly when it's blasted like that. It really doesn't look very nice at all. The next question is, why not use walnut shells? Everybody likes to talk about walnut shells. I have walnut shell here, and we sometimes use it in the bead blast cabinet. We'll change it from bead to walnut. has a couple of uses, but cleaning up corroded aluminium is not one of them. It's very good for for evening up the finish of a part that's been bead blasted. It gives a slightly duller finish, and it's very satin. It's very easy with walnut shell to smooth the finish and give it all a very even. You get a little bit of patchiness from bead unless you're very careful, and it's very good for smoothing that out. So it's sort of like a satin polishing. So it's quite good for that, but not much else. And then the final one is, why not vapor blasting? Everybody loves to talk about vapor blasting. Vapor blasting is just wet bead blasting. So all the downsides of bead blasting are still there. You still fill everything with bead. The only plus is you wash the dirt away as well as clean it with bead. Now, to be honest, having done both processes side by side, I would say there's not really much in it, and I don't have a vapor blaster, so I'd stick with the bead. The end results, if you put them side by side, are broadly similar. Possibly the vapor blast is very slightly shinier and very slightly cleaner, but most of that depends on keeping the bead in good condition, and a lot of that comes down to the fact that you generally are limited in the pressure you can run on a vapor blaster just by virtue of the water. The water almost cushions the impact of the bead, stops it breaking the bead up. What tends to happen with bead blasters, people crank the pressure up, the bead smashes in contact with the surface and then abrades the surface and leaves it rough. Whereas what you should do is keep the pressure low, and the bead will then stay round and actually peen and shine the surface up as it works. So that's the background to all that and why we've done that with that block. Going off on my usual tangent. Then there was a couple of questions, if I can actually see them now. I'll pick up on two. One of which was from William Freret 6859, 16 hours ago according to this. Why not using the milling machine to directly machine an epoxy tooling board block to create the mould instead of creating a master then a mould? And this is for, I presume, is referring to the Allegro front and rear wings, where we're machining a buck in MDF. Well, there are several very good reasons. I thought we touched on them, but I will mention them again. There are two particularly good reasons. One, it's extremely expensive to machine those, to machine moulds directly from epoxy. Epoxy tooling board is very, very expensive. Much, a huge magnitude more expensive than MDF. And there's absolutely no way of backtracking then. If you make that mould and you machine that mould and it's wrong, it's wrong. All your money's gone. So you spend, let's say, £20,000 machining some moulds, and they're wrong, then you've just thrown £20,000 away. If you machine them in MDF, the cost will be a lot less than £20,000. Let's say half that. Might be a little bit less than that, but certainly would be half. If you machine the bucks in MDF and there's something you don't like about the shape, bearing in mind up until this point you've only ever seen it in CAD on a computer screen, you've not made a clay model because that's another cost in. When we're making ones and two offs, we don't have the luxury of being able to do many iterations, otherwise the cost becomes insane. If your first step is the buck, the CNC machine buck, if you machine that buck in MDF and there's a bit you don't like, you can sand it, you can add filler, and you can adjust it manually after the CNC operation before you take the mould. And then there's another phase to this, which is if you're making a very small number of panels for a couple of cars, i.e. prototype cars, which is effectively what these are, if you make a one-off mould and machine it once in epoxy board, and there's a problem with the mould, and you can have all manner of problems that can break a mould. If you damage the mould, or you get a failed release, or something horrendous goes wrong, your mould is scrap. If you take a mould of relatively cheap vinyl ester and GRP, vinyl ester and glass fibre mould off an MDF buck, and something goes wrong with the mould, you can make another mould pretty cheaply. It's just a case of laying it up and taking the mould again. So it's relatively cheap to produce the mould from the buck. The expensive bit is still the buck, but you can still adjust it before you take the mould. So it gives you, basically, there's a significant cost reduction versus machining the mould directly. And it also gives you the chance to adjust if there's a problem. And it means that also if there's a problem with the mould in use, you haven't scrapped your one and only mould, you can make another one from the buck that still exists. So as I say, there are a couple of extremely good reasons why to do it that way. Now there are times when you won't need to do it that way. There are times when there's enough leeway in the whole process and enough reductions in the chance of failure that it is actually worth machining the mould directly. But it's quite unusual. Most of the time you're better to machine the buck, take the mould off the book, and you've got a second chance then. You've got a second chance at that point, and if something goes wrong with the mould, you can always make another one. You've still got your original master. So there's a lot of videos about that sort of thing on YouTube. There's a guy I watch a little bit on YouTube called Dark Aero. I believe it's called Dark Aero in the States, that make carbon fibre aeroplanes. And he explains what I've just explained probably a lot better than I've just explained it. And the points he makes, he doesn't use MDF, but he makes the points extremely well about the same sort of thing. And I've now forgotten what the other question. Oh, I know. The other question was, I'd seen a comment. I'm not going to pull it up now because I probably won't be able to find it. There was another question about the Jensen rear end. I thought I'd explained all this, but maybe you missed it, or maybe I didn't explain it as well as I thought. But one of basically the major reason that we are re-engineering that Jensen rear end, the Heights rear end had been fitted to that, and it's not the Heights part that was the problem, is because of the brake torque. Now, there was a comment saying that upper wishbone can't react to any brake torque. I know the upper wishbone can't react to any brake torque. That's precisely why we're moving the brakes back to inboard, which is where Heights had put them. Heights designed that wishbone setup to be inboard brake. I totally agree. I don't think that lower wishbone is capable of fully supporting the brake torque. I don't think it's far off, because it's actually surprisingly strong. And the same commenter had also made a comment about the drive torque reaction, the drive force. Now, I think it's fine to resist the drive force. It's just that the brake torque reaction can actually be more. And the worry is if you get a flex in the brake torque reaction on the rear axle, you can actually get wheel hop, which is something you really don't want under braking. But in the drive force, I don't think it's a problem with that setup. The lack of a diagonal member, the arms are triangulated enough that the lack of a diagonal member isn't really an issue. I've done lower wishbones with no diagonal members before. You don't need them as long as the forces are resolved through the wishbone correctly. So that's not really a problem. But the brake torque is a problem, which is why we're moving the calipers inboard, and that was always the plan, and that's the reason why we're doing the re-engineering work on that. So that's that. At that point, I'm going to hand over to Cal. I'm going to say Merry Christmas, everybody, and yeah, we'll see you in the new year, and we'll let Cal take you through the assembly shop.
Oh, thank you, Nat, and welcome to the CAD layer. I'm going to start with what George has been on with. So we've obviously showed a couple of weeks now of the initial progress on the Quattro project. It's very much in the initial just roughing out of shapes stage, but I have to say it's going insanely well. I'm not sure, I'm hoping George thinks the same, but it's like, it's one of them projects where rather than just beavering away for hours on end making tiny changes and not being entirely sure, it feels like this has kind of dropped in as an initial rough out, which is like 90% of the way there. So yeah, it's looking absolutely awesome. I mean, we mentioned before we started by modelling some wheels and getting them in the model at the position we wanted, and then using that to get the sort of dictate the arch width. I mean, I think I'm right in saying it's looking like we're going to be able to keep the door shape standard.
Yeah, that's standard.
Yeah, which we were wondering. We didn't know if it'd be possible to get the width transitioned back into the standard door shape and it look half decent, but actually it's gone fine. There's definitely more than a smidgen of the Sport Quattro look about the arches, which I think is coincidental more than anything. Despite there being a Sport Quattro open there, I think it was like model the arches to cover the wheels, and the way they took shape just happened to look a lot like a Sport Quattro arch.
Pretty much.
I'm liking the air intake shape a lot more than the sort of suggestion of one that you have on a Sport Quattro, and then the front end's looking absolutely awesome. The intention is that these sort of side light matrices, if you like, here will actually motorise out the way for the main headlights. So we'll have like a Hella LED projector unit behind here, and this will be quite a thin unit that we'll make with machined acrylic and LED units behind it and a circuit board in it. That'll exactly like that, move out the way, and reveal the headlight when you actually turn the headlights on. In fact, actually another thing we've done this week was model a 3D print, there it is, of these Hella LED units we've used, because we've used these in a few cars now. We thought, and they're reasonably expensive, so it'd be nice to have a 3D print so we could do that, but also meant we've got a physical model, we've got a virtual model to try in the CAD. But then when the guys get to do the metal work, we've got the 3D print so they can actually use that for mock-up on the car itself. So yes, this is looking pretty good. There's still a long way to go. George is obviously just taking some initial work on the rear end at the minute. The rear light shape we're actually thinking of keeping reasonably standard, but incorporating that kind of cubey matrix look into the lights, and then extending that across the back here as well. But I'm guessing you're working mainly on the rear bumper at the minute.
Yeah, just the whole rear end in general. I'm just trying to mock up that kind of area just so it visually looks correct, and then I'll start fettling the rear end again, like splitters and bumpers and all that kind of stuff.
Yeah. But I think as initial kind of couple of weeks on it goes, it's looking pretty darn good. So I'm pretty excited to see that continue to take shape. And Luke, in the meantime, is working on E-type dash. So we're progressing towards this point we want to be, where we can start actually making some of the core components of the interior to allow us to, Fusion's probably just crashed, to allow us to do some of the metalwork on the shell. So we've been modelling the centre console and the basic shapes of the dash, so we can throw that back and forth with the customer to basically make sure he's visually happy with it, and also some of the mechanisms that are involved. So we're doing a screen rotation mechanism on it, which initially we roughed out as like a quadrant that rotated with the screen one side and a dash fascia piece the other. Now we modelled that and it just wasn't going to work out. No matter how you did it, there was going to be a void in front of the screen when it was in screen mode. So we changed it to having like a fixed screen and then a dash piece that actually comes down in front of it and slides away underneath. And when it's slid underneath, it forms the sort of return edge that leads to the screen recess, and it does that really nicely. The curvature of the dash fascia works really well. So we've done that. We're happy with the basic console layout. We've had a few sort of to and fro's with the customer. So we started with cup holders on it. We've now decided to change our mind on that and put like a phone tray in the centre console. He's moved on to roughing out the bezel that will go around the gear shifter. We're going to have a start button on the back of that, or at least that's the current plan. And then the instruments, we've kind of refined how we were going to do those. We weren't sure whether to have them slightly proud or slightly recessed or very recessed, and it's looking like it's going to go in the direction of them being quite recessed. And then we're just moving on to other components we've got to get in there. So the air vents, for instance, we're just modelling some of the Resto Mod air vents that we're planning on using, working out how they'll integrate with the curve on the dash, because where the original E-type dash is totally flat, we're hoping to curve our dash fascia around and then transition it into a similar finished panel on the door card itself. So this, what will be probably a gloss black finish on there, will sweep rounded onto the door card. Then we've been modelling things like speakers as well. So we've got these Morel Virtus Nano speakers, which, if you haven't come across them before, are very good for tight spaces, because despite their extremely slim shape, they do sound absolutely incredible. So on a car where space is at a premium, which includes actually at the minute the Allegro, I think these are going to be used on that as well. So we're looking at these potentially in the side of the centre console. So again, modelling stuff like that so that we can actually trial it for space in the virtual world before we go to the real world. But we're getting pretty close, and what I want to do is get to the point where the centre console, which is all of this section down here where the speaker is sitting, all of this fascia section up to the bottom of the screen, so all the area where the shifter comes through, the bit where your phone goes, the cubby hole under the armrest, all of that is going to be one moulded fiberglass or carbon fibre piece. And what I want to do is get to the point we can make that, and we'll also have the mechanism for the screen planned and the dash fascia planned, so we can fabricate the dash fascia. And then with the combination of having the centre console fiberglass piece and the dash fascia components, we can then physically put them in the car and actually build the mounts on the car to suit those pieces. So yeah, things are coming together, and at this point now it also allows us to work out roughly where we're going to start situating electronic devices and other things we want to hide away. Another thing the customers was asking if it was possible, was whether to have if you could get hot air vents to the back to actually get hot air around your neck, a bit like some of the Mercedes, they call it an air scarf, I think. So we were trying to work out whether we could get ducting underneath certain parts of the console, which now we've removed the cup holders and slightly shallowed the cubby hole under the armrest, it's looking like we could, because what we'll do is we'll run sort of full-size ducting down there, and then under the cubby hole where it's a bit slimmer, we can 3D print a relatively slim duct piece to sit under there. And then once it gets to that rear deck area behind the seats, there's quite a lot of space there, so we should be all right for space there. So yes, it is looking pretty good, and I think we're probably a couple of iterations and back and forth discussions with the client away from actually being able to pull the trigger on machining the tooling to make that main fiberglass centre console piece, and that's kind of will be the cornerstone then to then allowing us to sort of construct all the rest of it. But we've got a pretty good plan in place of how it's all going to be made now, where we're going to hide fasteners away. So these tan sections that run down here, they'll likely be fabricated in aluminium, foamed and upholstered, and those parts are going to clip in place, which means that we can put fasteners to attach the rest of it hidden under that area, and then the clip-on parts can go over the top. And that's often a sort of technique we use on quite a lot of interior stuff, is thinking through the order of events such that you can put things together in a sequence with visible bolts, but then the very last part is a clip-on piece that then hides away all the fasteners that you put in place before that. So yeah, looking extremely good. Kind of it's at that peak excitement time now where I can visualise exactly how it's going to look in the car, and looking forward to actually making that happen. Right, we'll have a wander out here. Wiring zone. So Alex and Steve have been working extremely hard on this to try and push the wiring on the Escorts through as far as it could get before we stopped for Christmas. So Project 1 main harness was in last week. Project Kuma's main wiring harness has now been duplicated from the first one. That's in that car. A little bit of termination left to do on that, but not too much. Then they've been building the rear harness, which for Project 1 is being installed by Steve at the minute. It's mostly in place, a little bit of termination left to do again. And then this is the second rear harness, excuse me, except for this bit here, which is this is the in-the-car engine harness for Project Kuma. The Project 1 version of this is already in place, but this is basically just a very small loom that goes from the engine ECU as a join into the main chassis harness, and then a bulkhead connector which goes to a Deutsch Auto Sport connector on the bulkhead, which I think would be, yes, one of those, which will then be where the actual engine management harness is integrated into that. But yeah, this is the rear loom just being roughly laid out for Project Kuma, and it's actually quite a convenient moment to show some of the sort of schematics. So this is the schematic that's been done for this very small loom here. Likewise, over here is the one for the rear harness, and this basically documents every wire that's in there, the colour, the gauge, has details of all the connectors, the part numbers for those, and this is basically the instruction sheet that whoever's constructing this harness will need to put it together. And this is what Alex has put together in his design phase. So then Steve can take over where necessary and do the actual build of the harnesses. It's not the neatest, I must admit, at the minute, but you've got the wiring laid out here with measurements on here, so we can sort of spool it out, cut it to length. This is all Raychem Type 44 wire, which is just a fairly typical specification when you're doing high-end motorsport wire. It's extremely abrasion resistant, very small cross-sectional area for the current carrying capability it has. So you can have wiring harnesses that can have a lot of wires in them, basically carrying a lot of current and take up a very small amount of area. If you compare it to something like the Lucas wiring that you would have had on like a Jag or an E-Type or something back in the day, the wires they would have had to take the same current as something like this tiny little wire here would have been probably 3 or 4 times the diameter of that, and nowhere near as abrasion resistant. It's sometimes if you haven't got exactly the right tools and you just jump on a job, grab the nearest pair of wire strippers, you can almost be frustrated by the abrasion resistance, because it's actually quite hard to strip sometimes. We're obviously using really decent stripping tools that actually sort of cut and pull the insulation off. But if you remember those sort of auto strippers you get where it just comes in like this and automatically pulls, if you try and use that type of stripper where it's only kind of going on 2 sides of the wire, it almost never actually properly strips it, because it's that resistant to the damage. So that's that, and then it's also worth noting while I'm here, just because there happen to be a couple laid out, we talked about documenting things electrically before. This is the sort of stuff we're doing. So any components that go into the electrical system, we do data sheets for them, which means that going forward, A, as a reference for the customer for this car. If anybody's working on the car, they've got all the data sheets for all the components in it. But it also means that if we use the same components again in future, we just have to pull up the data sheet, and we've already got details of the part numbers for the connectors we need, the pin layout for it, any other details essentially. There's a pin out on the back here of what all the pins are on these. So these happen to be these audio components. This is the Audison Forza amps that we're using in these Escorts. Extremely compact, but extremely powerful as well. And what we're doing is we're doing individual channels for each speaker, because you can control within the software for these the exact frequency range for every channel or every output channel on this amplifier. We don't need any kind of crossovers in the audio system. We're literally connecting the tweeters to individual channels on here, the mid-range to individual channels, the bass drivers to individual channels, and then you connect a laptop up to this amp and then program in essentially what frequency range you want to go to each channel. And then this beacon on the top here is the Bluetooth receiver. That's connected with an optical cable, so it's digital all the way from the receiver to the amp, so there's no analog signal until you get to the speaker level. Speaking of which, that is what a lot of this wiring harness is, the chunky bit, where unfortunately we move away from the beauty of having the really thin wires. Is with the speaker cable, we've got relatively heavy duty wiring in there, just absolute minimal resistance in there, trying to maximise the sound quality. So a good amount of the rear loom or chunkiness of the rear loom is speaker cabling. But yeah, this one's coming together, the other one's in the car, so we are moving forward wiring wise. I mentioned briefly about wire stripping earlier, so these are the very good value but very good strippers that we use, Strip Masters. We've got two different ones. I think that's the bigger gauge one, and there's another one we've got for the smaller gauge wire. But yeah, very good for decent stripping of wire where it does a cut all the way around the insulation and doesn't kind of drag on the cores. Right, moving on from that, I'll briefly touch on E-type down there. So James has been carrying on with the belt train on that. He'd got to grips pretty much with the alternator belt. We were now looking at the power steering pump. Now the power steering pump arrangement was a kit that we bought, but the tensioning arrangement on that power steering pump we weren't very happy with. So Jim's basically designing and making an in-situ adjustable tensioner arrangement on that. It also holds the pump in a slightly different position, just to give us a bit more clearance when it comes to the AC compressor. So he's kind of got the alternator position, belt tension all sorted, power steering pump position, belt tension all sorted, so that leaves the remaining one, which is the aircon compressor, and that will be probably started on in the new year. We'll get that compressor mounted, work out the mounts for that, how we're going to do the belt arrangement on that, and it will be actually 3 separate belts on this. But yeah, it's progressing well, so it'll be nice to get all of that belt train stuff sorted. And then going back to Escorts, few avenues of progress. Obviously I mentioned on project 1 about the wiring harness and the bulkhead connector that transitions to the engine loom, and what we've been waiting for in terms of designing the engine loom was actually the cam cover, which I think you briefly saw last week, but we've got that cam cover back from machining now, and it serves a couple of purposes, the design we've done for that. Obviously it covers the cams and keeps the oil in the engine. It also mounts the coil and plug units we wanted to use, but then we've done an upper shell to that cover so that the wiring to the coil packs can be completely hidden, but it also gives us a nice little conduit to run the wiring through for other parts. So there's a little notch out at the front and at the back to suit a little sort of capital D-shaped grommet, where the wiring will enter at the back, completely hidden at the back of the engine, and then obviously feed the coil packs, and at the side near the front will be the wiring to the coolant temp sensor and down to the crank sensor. So now that's here, and we'd also, I neglected to mention then, we put little threaded bosses in the lower cover so we can clip the wiring in there. Now that's on, Alex can do a really accurate measure up for the routing of the wiring there and how it's going to run through those clips. So he can do the design for the engine management harness, which with all of the trauma of the scale of the job on the rest of the wiring harness should be relatively straightforward. Then we can get those made, get them in. So yeah, things are looking pretty good on that. We also got the door cards back last week. I don't know if were they shown, Jamie, last week? Yeah, okay. So the door cards came back. I've now sent away the 3D printed speaker surrounds on all of the rear end trim panels. So the floor panels, rear bulkhead, parcel shelf and fuel tank cover panel, they've all gone away to be leathered. So once they're done, we're kind of down to carpets the rear section of the rear parcel shelf, which I haven't sent off yet, and I think there's, and the cage, which we're going to upholster in situ on the car. But what I want to do in the meantime is get almost all the rest of the interior in. I'm leaving the glazing out intentionally, so the car kind of is further on than it looks like it is because it's just not glazed, but I don't want to do that until we've leathered the cage, because the access to the cage is going to be hampered if there's glass in there. We've also, with that cam cover back, that was the final piece in the puzzle in the bronze anodizing batch. So there are various highlight or accent coloured parts on the car, things like the fuel cap, instrument bezels, but the one last piece we wanted to do bronze was the cam cover, which is actually going to be predominantly black, but we wanted the raised ribs and our logo to be bronze, and the best way we could come up with doing that was to do bronze anodise the whole thing and then mask the tops of those and then paint the rest satin black. So yeah, that's bronze anodising batch together. I think that's literally en route to majestic anodising on this instance. Normally we use mill turn for most of our anodising, really quick turnaround, great stuff, but they're only set up to do the kind of key colours, whereas majestic are much more flexible when it comes to any colour of the well, not any colour of the rainbow, but anything that can be anodised is not too much of a job for them. So I look forward to getting those bits back. Only sort of slight complication on these this week. We've been putting fluids in them, getting things bled up, etc. We filled the diffs, and immediately the oil started to pour out of the diff on this one, and then on closer inspection it was dripping out of that one as well. And we've discovered a massive bit of porosity in the casting on the diff casings, frustratingly. So both of the diffs are now back out of these to be sent away to have new casings put on them, which is it's a slight frustration, but I don't think it's really going to hold us up massively anyway, because we're waiting for various interior parts on them. But yes, very much getting to the point where interiors will take shape. That car should take shape pretty quickly. Hopefully the engine will be here first thing in the new year for this one, and we're just waiting on some final colour choices for the interior. But that one should be in a position to take shape pretty quickly in the meantime. On that note, that's probably covering about everything, and I'm actually mindful of the fact that this is a Christmas Eve release, if you like. So, although what I would like to say before we go and say Merry Christmas, there are two members of staff who are leaving us at the end of this month, or basically tomorrow will be their last day. So Rich, who I think has been here 5 years, and Scott, who's been here 6 years. And it's been I was going to swear then, it's been a very, very good journey, a really enjoyable journey with both of them. Scott, I remember approaching us at the NEC at a classic car show, which must have been maybe 2016, I would guess. We had a stand there, and I think he must have been, I guess he was fresh out of school basically at the time, and just approached us very, very enthusiastically. No experience whatsoever, and we basically took him on as an inexperienced apprentice metalworker, if you like, and he's kind of worked his way up to being an extremely capable fabricator. Frustratingly, so capable that he's now going to Aston Martin to do fabrication there. But I sort of, after momentary feeling kind of frustrated to be losing a good guy, the overwhelming feeling really is just pride of having kind of brought this lad from not much skill to being able to sort of pursue his sort of dream career. So very excited for Scott. And then Rich, who has been here 5 years, I think, much loved member of the team, although slightly calamitous on some occasions. But he is now going to be enduring fatherhood as basically, initially at least, a full-time dad. So it'll be interesting to see what calamities he can get up to as a father. But yeah, as I said, much loved, very valuable member of the team, and it's sort of sad seeing people that have been here for so long move on to do other things. But then likewise, I just have to kind of be enthused about who the next Scott and who the next Rich are going to be. So yeah, 2024 will no doubt reveal new guys here and new journeys to embark upon. On that note, I'm going to go down here and we're going to sing Christmas carols together. But on behalf of Retro Power, thank you for watching throughout 2023. Hopefully 2024 will bring some awesome projects. So Merry Christmas. Merry Christmas!
Scott and Rich are both leaving us on Friday after 5 and 7 years each. 7 for Scott.
7 years in Jan, yeah.
Yeah.
6 for me.
And yeah, just basically wanted to get you both to get your thoughts on working at Retro Power. Scott is off to Aston Martin, and Rich is off to be in charge of raising a child. These are both monumental, significant things.
Yeah. Big steps. Yeah. Rich, you're not helping here.
I very
You're not
rarely
helping.
do.
Yeah, it's been noisy, dirty, a lot of rust to deal with, but it's been good. It's been good. I'm no good at looking at the camera.
You're doing quite a good job of looking at the camera right now. You're looking directly at it.
I'm good at looking at the camera when I'm not supposed to be.
And Rich, what's it been like working at Retro?
Yeah, it's been quite good. It's been quite varied. I turned up and there were 9 people here, and we just had a Christmas party with 31. And I still don't really know who all the extra people are, because it's... Well, I know who they are, apart from that one bloke. Yeah, it's never really felt it's growing until you sort of count things up. So I guess that's
until you've
quite
got
good.
everyone together, you never realise how big everything's actually got.
Yeah, it still feels like a small company, I think, which is probably...
Kind of.
Yeah, quite a good thing.
Yeah.
Yeah. You need more questions than this.
Yeah.
Otherwise,
Yeah.
the entire thing is
You
just
should have
going to
thought
be me
about this a bit more, Jamie.
staring at Scott and making him nervous.
Well, yeah, I was.
Yeah.
Fuck it, okay, fair enough.
If you want to answer the poll, which is Scott's hairline receding, then we can take a sample of how 500 a lot of people on YouTube, and if I should have a haircut, which we kind of know I should have a
fair
haircut.
trade. You chop your hair off and donate it to Scott.
Once I leave here, I'm going full corporate. I used to wear a suit for work.
Thanks, guys. Good luck in your endeavours.
Don't use any of that.